Hi, I'm going to explain about common source amplifier. In common source amplifier, we know that the source is common for both input and output side. So then it is a common source amplifier. We know that FET is having source, gate, drain terminals. So here the source is common. We can say this for input and outputs. I'm assuming this is an output and this is the supply required VDD, and this is an input. Across the gate and source we are giving the input signal. So then it is a common source amplifier, and we know that the source function, common source amplifier function is, while giving the small signal, it should be amplified by the amplifier. Then it is a common source amplifier. Of course, by setting the Q point we can get the output without any distortion. By using biasing resistor R1 and RD and R2 and RS, we can get the output without any distortion while giving the supply. So every amplifier is having particular frequency range to amplify the signal. For example, I am assuming this is the range for given amplifier frequency range. So this is an low frequency range and this is an high frequency range for the signal. So at the low frequency you may get the distortion, at the high frequency range also you may get the distortion. So every amplifier, it is having particular frequency range to amplify the given input signal. So coming to the small signal analysis, we can say this: we can find the input impedance. What is an input impedance for the circuit? What is an output impedance of the circuit? What is the voltage gain? And what is the current gain? We can calculate the mathematical equivalent equations by using small signal analysis. So that is the small signal analysis. For that I will draw this equivalent circuit for small signal analysis. First we need to draw the current to draw that. So first we need to draw the current for transistor. Here you can see this. So this is the current at the transistor, GM into VGS. Why it is GM means, for example, GM multiplied with VGS means, here GM means transconductance, that is output voltage, output current by transconductance is equal to output current by input voltage VGS, voltage between gate and source, multiplied with VGS. So then VGS cancel and the remaining is IDS only. So that's why here they can write like this: GM multiplied with VGS. And coming to the output resistance in the circuit, you can see this: RD is the drain resistance at the output side, RS is the source resistance is the output side. So I will write here RD, here we can write this is RD and this is RS. This is source resistance RS. Both are in parallel. Why? Because here output is there, output line, we can say this. That's the reason RD and RS both are in parallel. So we can draw like this. So then the equivalent output small signal analysis output side is completed. So we can write it as this is output impedance Z0. Coming to the input side, you can say this: input side is having R1 is there, R2 is there. So both are in parallel. Anyhow, it is not in series. So that's why input side I am writing R1 is parallel to R2. So here I am writing here R1 is parallel to R2. So this is the input side, and now so this is plus and this is minus, and this is input impedance Zi. So now the small signal analysis completed. Now we can find what is an input impedance. Input impedance or input resistance. First I am finding the input resistance across this R1 and R2 only, input side. and output resistance, you can see this RD parallel to RS. So I am writing here input resistance Ri is equal R1 is parallel to R2. That's it. We know that R1 parallel to R2 means R1 R2 by R1 plus R2. So this is an input resistance, and coming to here, and this is R0. I am writing output resistance is R0 equal RD is parallel to RS, or else RD multiplied with RS by R1 plus RD plus RS. So then I will write it here. What is an input impedance? I will write, we need to find the input impedance. Here Zi equal input voltage by input current. Input impedance is equal input voltage by input current, and we can write it as II multiplied with resistance Ri by II. So II cancel, so this is equal Ri, but we know that the input resistance is equal R1 parallel to R2. That's it. So this is an input impedance Zi. We can calculate the circuit impedance by using this small signal analysis for any given circuit. This is an input impedance Zi. Coming to the output impedance, Z0 equal I0 into R0 by R0, or else we know that V0 by output voltage by output current. So now we can see I0. So this is I0. So I0 cancel, and R0 is there, but R0 equal we have found already. So RD parallel to RS. So I am writing here RD parallel to RS. That's it. This is the output impedance. Coming to the voltage gain AV, voltage gain equal V0 by output voltage by input voltage is the voltage gain. Voltage gain equal output voltage by input voltage, or else you can write it as I0 into R0 by IA into RI. So I0 by IA means AI, current gain AI, multiplied with R0 by RI. But we know that AI is equal AI into R0 means RD parallel to RS divided by RI means R1 parallel to R2. So this is the voltage gain. Like this we can find any circuit impedance. Input impedance we can calculate, output impedance we can calculate, voltage gain or else current gain, everything we can calculate. Thank you.